100 degree, which is my answer. Okay. In this question, we will be using the concept of relative velocity that we learnt earlier. So the question is, at what time do the hands of a clock between 7 and 8 form 90 degrees? So just imagine the clock again. So that's your clock. So initially the angle between the hands of the clock, we take this angle always from the right side, is 7 into 30, which is 210 degrees. Now when I start moving the minute hand, this is only for your visualization. So this is somewhere where approximately this angle is 90 degrees. So what you need to see is that relatively the hands of the clock have shifted by how much? Initially the angle between them was 210 degree initial angle. What is the final angle? We know that it is 90 degree. So how much has the angle changed? The angle has changed by basically 210 minus 90 degree, which is 120 degree. So basically roughly you remember this hand was like this. Assume that this was fixed. So the minute hand has moved approximately this much. Just for your understanding, it's approximately 120 degrees. So this is just for you to sort of check this also. So relatively, this is what we get, that the degrees between the two hands has changed by 120 degrees. But is that all? Is that the only way that I could have gotten 90 degrees? If I this is once when I get 90 degree, when the hour hand is ahead of the minute hand. Now if I continue doing this, you will see that eventually before 8 o'clock there will be another point where the angle comes out to be 90 degree. In this case, what we do is, instead of subtracting 90, we are basically adding 90. Why? Because initially, if you see, this angle has increased a lot now, because we won't take this angle. Now the angle to be taken is basically this. So in this case, what you do is 210 plus the final angle, which is 300 degrees. So now my relative angle is 120 degree and 300 degrees. Now as you know, the distance traveled is equal to speed into time. Here we are trying to calculate the time. Now time is equal to distance, which in this case is the relative angle divided by the relative velocity. So in this case, the time that we're trying to calculate is the distance, that is relative angle. Here let me take this first, is 120 divided by the relative velocity I told you was 11 by 2 degrees per minute. So when I solve this, I get 21.9 by 11 minutes. Similarly, let me take this. Again, my relative angle is 300 degrees divided by the relative velocity. I told you to remember this number, 11 by 2. When I solve this, I get 54.6 by 11 minutes. So at what time? It is basically 7 o'clock plus these minutes. So you can solve it in whatever form the question, the answer choices are given to you. 7 plus 54.6 by 11 minutes. So whenever you have these kind of questions, all you need to do is calculate the initial angle from the first, between this and this. So this is this number multiplied by 30. So this is how you calculate the initial angle. After that all you need to do is to add and subtract the final angle that is given, and then divide it by the relative speed, and you will get the answer to your question. Now in case we were not doing it by the method of relative velocity, we'll also try to show you how you could have done it by the conventional method. In that case, basically you will be needing some amount of algebra and some equations will be formed for you to be able to solve the question. Okay. Now in this case, in case we were trying to use the normal algebraic method. So let's say the time when this happens is t. So in t minutes, your r hand would have traveled t into 1 by 2 degrees, because the speed is half degree per minute. So these many degrees would have been traveled by the r hand. Similarly, the minute hand would have traveled 6 into t, which is 60 degrees. Now look at the clock again. So this is your clock. So this is your initial angle. Initial angle is 210. Now in this the r hand is moving forward, and your minute hand is, again, your r hand is trying to increase the degrees and your minute hand is trying to reduce the degrees. So initial is 210 plus the r hand is trying to increase, that is t by 2, minus the minute hand is trying to reduce, minus 60. Finally we get 90. So we solve this equation, and basically this is the same as if you take these to that side, and you get 120 is equal to 11 by 2 t. So t comes out to be 21.9 by 11 minutes, the same as we got earlier. Now for the second angle, the second time that we were seeing, so you now look at this again. Now what is happening is, I'm moving the minute hand, and instead of stopping here, I keep going forward, and I stop somewhere here. So as you see, the minute hand has traveled a lot of distance, and this r hand is trying to reduce that angle. So in this case, what we will do is basically the distance traveled by the minute hand, that is 60, and from this we subtract the distance traveled by the r hand, that is t by 2, and also we subtract the initial angle. So this is the minute hand, and this is the r hand, and this is the initial angle, and this has to be equal to 90 degrees. So as you understand, I am doing this because eventually the minute hand is ahead of the r hand. So this is how we solve it in this case, and when you solve this, you get t equal to 54.6 by 11 minutes, exactly what you got in the previous case.